Hello, and welcome to this online event titled Why BESS Designs Get Frequently Delayed by Repeated Tasks During Design and Development. We believe we have got some great topics to cover of how you can prevent some of these bottlenecks. And that's why we are very much looking forward to sharing some of our experiences with you today. During this session, we will guide you through 3 challenges, corresponding approaches, how to overcome these challenges, and there where we believe we can support you with the purpose of faster, better, and more innovative design, integration, and manufacturing. All this in order to help you realize your go-to-market BESS ambitions quicker. What's more, we will also take you through a number of use cases and real-life examples, which we envisage will be of value to you. Why do we do that? Is because in doing so, it is our aim to demonstrate not only some of our expertise and wide portfolio, but also to give you the confidence of working with nVent as a true BESS co-development innovation partner. But before we kick off, we'll do a quick round of introductions. With me today, I have Saran Karim and Robin Vosel, who will introduce themselves in a moment. To start off, my name is Edwin de Boer, based in the Netherlands, and I've got a global role as marketing manager for nVent, focused on a number of high growth industries, such as the energy one. And today I will be your host during this online event. Saran, could you please introduce yourself to our listeners? And after that, can you do it followed by Robin? Robin as well, please.
Thank you, Edwin, and hello, everyone. My name is Serhan and also based in the Netherlands. I work as a business development manager around electrical energy industry for nVent. My focus is on driving business growth and developing strategic opportunities in this area. Robin?
Thank you, Serhan. I'm Robin Vosel, based in France near the Swiss border, and I'm in charge of developing strategies, sharing them, and ensuring their execution across high-growth vertical markets in EMEA, such as battery energy storage system, which is today's focus. Over the next half hour, I will share key challenges and practical application examples to help make BESS design more efficient than ever. With that, I will hand it back to Edwin to introduce today's topic.
Well, many thanks for your introduction, guys. So we also would like to introduce nVent. So who is nVent? What I will do is I'll show you a 1-minute video to introduce nVent and why, because I believe it helps you better understand where we're coming from, what we can do for you, and also to set the scene for this session. And at the end of the video, Saran will take over and zoom in on some of the trends we're seeing that are going on, and then to go into the 3 challenges in BESS design. But without further ado, I will just start with the video, after which Saran will take over. Enjoy the video.
By now, it's a given that energy storage is a critical part of our sustainable future. And if you're an energy storage innovator, chances are you'd like to be a big part of that renewable future. But are you prepared to be? Can your existing systems accommodate future growth and changes in demand? Have you fully optimized the operational efficiency and performance of your vital controls, instruments, and electrical equipment? Do you have the right safeguards in place to protect your assets and business from threats? Are you under pressure to reduce operating costs? Are you maximizing energy storage efficiency and capacity utilization while reducing energy waste and costs? We can help make sure you say yes to each of those questions. Across our industry-leading brands, we offer a comprehensive range of scalable solutions to connect and protect critical energy storage systems and infrastructure. Our inventive electrical solutions optimize efficiency, resiliency, and safety. From smart systems designed to connect, control, and monitor assets in real time for data-driven insights and predictive maintenance capabilities, to electrical enclosures and climate control solutions that maximize performance and safeguard critical equipment, and more. We can help you evolve your energy storage systems to be smarter today and ready for tomorrow.
Over to you, Sarah.
Thank you, Edwin. And in this part of the webinar, I'll briefly discuss the energy transition and the challenges it presents, along with an overview of the key challenges in battery energy storage system design. We are currently experiencing a massive energy transition. With the accelerated growth of renewable energy, global electrification is advancing across multiple sectors. Electric vehicles, high-performance data centers, energy storage systems, and other electricity-driven technologies are increasingly shaping the foundation of our modern life and the digital economy. To fully unlock this potential, the digitization of energy is essential, enabling smarter grids, higher efficiency, and more resilient energy management. However, the increasing share of renewables in the energy mix also brings significant challenges. Next slide, please. As we all know, electricity supply and demand must be perfectly balanced at all times. The intermediate nature of renewable energy makes maintaining this balance more complex. That is where energy storage, and particularly battery energy storage systems, plays a critical role. BESS helps ensure frequency stability and prevent issues. Next slide, please. Such as blackouts, equipment damage, and even threats to safety. Beyond that, it also helps prevent reputational damage and financial losses that can result from grid instability. In short, BESS is essential to maintaining a reliable and resilient energy system as we transition toward a renewable powered future. As we recognize the critical role of BESS in ensuring grid stability and reliability, it is equally important to understand that designing and implementing these systems comes with its own unique set of challenges. On this slide, I would like to walk you through three main challenges typically faced and highlight what helps overcome them. The first challenge is avoiding the risk of reinventing the wheel. At the start of a new BESS project, it can be tempting to create completely new design. However, real success comes from building on what already works, proven scalable design that can adapt and grow as requirements evolve. That means having a scalable battery and thermal architecture ensures seamless system integration and designing for environmental and mechanical resilience, so the system performs reliably no matter where it is deployed. The second challenge is bridging the gap between prototype and mass production. This is where many projects get tricky. It is one thing, as you know, to make something work in the lab as a prototype, and another to make it repeatable, cost-effective, and scalable in real production. Here, design for manufacturability and assembly becomes critical. Keeping the design practical and easy to build. Using modular components helps a lot too, because it simplifies assembly, reduces complexity, and supports scalability. Thorough and consistent drawings are also essential to ensure clear communication between design, manufacturing, and suppliers. When combined with supply chain readiness and strong process validation, that help ensure that every system performs as intended. This approach effectively bridges the gap between prototype and mass production. And the third challenge is taking a holistic approach to compliance and testing. As BESS solutions expand globally, standards and certifications become increasingly complex. So standards should be integrated early in the design phase with cross-domain testing that covers electrical, mechanical, and thermal aspects, ensuring that systems are compliant and ready for development anywhere. In short, tackling all those challenges as early as possible with scalable designs, modular and manufacturable components, and a proactive approach to testing and compliance helps deliver best systems that are safe, efficient, and ready to power the energy transition. Now, Robin will dive into the first challenge, avoiding the risk of reinventing the wheel. Over to you, Robin.
Thank you, Serhan. Very well said. And when we talk about standardization and harmonization, it's important to clarify that this does not mean solutions must be always come straight off the shelf. On the contrary, the ability to tailor design to meet the specific requirements of each application is essential. This customized solution often become a template for future needs, combining flexibility and repeatability. Choosing the right partner is absolutely critical because factors such as thermal management, supported by advanced simulations, and flexible cable routine, which adapts to the design rather than forcing the design to adapt, directly influence the efficiency and reliability of the entire system. By working together, we ensure that every single design is not only compliant and harmonized, but also optimized for performance and scalability, while addressing what truly matters for the project: an affordable, realistic design that meets all needs, including technical features, timelines, safety, and cost. Looking at the middle column and its specific approaches, let's consider an example: an outdoor battery energy storage system based on a second life battery system located in central Italy, which is high in terms of altitude, which is a seismic area. And here, thermal performance is key. Corrosion resistant and snow load must be considered. Battery design will dictate certain constraints. Safe handling is essential due to the weights, and seismic risk mitigation is a must-have. Therefore, in the next slide, we are taking a very specific, and the one that we mentioned now, example. So let's imagine if designers take these challenges into account to create a new standard design that addresses more than 80% of these requirements, with modular options to cover the remaining 20%. This is how we combine harmonization with flexibility, creating solutions that are both tailored and scalable. Compactness, flexibility, smart option selection, and cost efficiency. These are exactly the points we are highlighting now and we discussed earlier. On this slide, you can clearly see the wiring design optimization on the left-hand side of the slide from left to right, ensuring a streamlined layout, and the snow load ready cabinet rooftop on the right-hand side of the slide, designed for durability, reliability in harsh conditions. This feature can be added as an option when needed, fully integrated into the standard design without requiring us to reinvent the wheel. Serhan, I give you the next one.
Building on the first challenge of avoiding the risk of reinventing the wheel, the next major hurdle is moving from prototype to full-scale production. A prototype can perform perfectly well in the lab, but it doesn't mean that during the scaling up, it will do the same. In the scale up, there might happen some issues, unexpected issues. For example, components like an indoor chiller or enclosure may no longer fit within the mechanical footprint, and assembly can become more complex and costly than anticipated. Mounting points may conflict with local seismic codes, and long lead times for custom components can stall production. Even the lack of detailed technical drawings from the prototype phase can make replication at scale very difficult. The lesson is clear. Success in the lab does not automatically translate to smooth production. So, how can these challenges be managed? Start with raw technical drawings and modular designs, which allow proven prototype elements to be reproduced reliably at scale. Optimize layouts as early as possible to prevent component clashes, and use standardized parts to simplify assembly, reduce costs, and speed up production. Plan for supply chain readiness and realistic lead times, and design for manufacturability to ensure processes are repeatable and efficient. Finally, ensure clear communication across all teams, confirming that components fit, mounting points meet standards, and safety and seismic regulations are accounted for. Following these steps effectively bridges the gap between prototype and mass production, turning a promising lab result into a reliable and scalable solution. Next slide, please. In projects with several customers, we face the typical hurdles of moving from prototype to mass production. Space constraints, long lead times, and design complexities could have slowed us down. However, thanks to our robust in-house manufacturing capabilities, our focus on standardization, modular designs, our thorough technical drawings, we were able to navigate these challenges and scale up smoothly. For instance, for one customer, after the prototype was approved, they requested easy access to the chiller. As you know, chiller is a critical part of the cooling system for battery energy storage systems. Rather than relying on external suppliers, our custom designs, we fabricated chiller access component in-house. This gave us full control over quality, fit, and production timelines, helping us avoid delays and deliver exactly what the customer needed. For another customer, just before starting mass production, they requested special charging pillars and plinths to simplify installation and transportation. By designing and manufacturing these components in-house, we ensured they met the exact specifications required at scale, which also making it easier to move and assemble the solution efficiently. In yet another case, a customer had successfully built the prototype in-house, but struggled to transition to mass production due to incomplete technical drawings, poor connection methods, and the lack of modular components. By applying proper technical drawings, modular designs, and the standardized connection methods, we were able to mass produce the system reliably, ensuring consistency, efficiency, and scalability. These examples show how proactive design, modularization, and in-house manufacturing can turn prototype success into full-scale production, overcoming common hurdles and delivering solutions that meet each customer's unique needs. This combination of in-house fabrication and a focus on standardization, proper technical drawings, modular designs, allows us to deliver high-quality, scalable, BESS solutions without the typical delays or complications, ensures a smooth and efficient transition to full-scale production. Now it is time for our last, but certainly not least challenge. Over to you again, Robin.
Thank you again then. Compliance is not one-time checkbox. It's an ongoing process. I guess we all agree on that. Because every design phase can introduce new challenges, wherever it's cooling, venting, vibration protection. We keep testing and adapting continuously. Why does this matter? Because safety standards like UL 9540A require rigorous fire testing from cell to module and to full installation. Missing these steps can lead and will lead for sure to costly redesign and delays before deployment. Thermal simulations, for instance, help engineers identify hotspots and critical thermal pathways in battery modules and rack before they occur in real-world condition, and potentially add liquid cooling solution if requested. By simulating worst-case scenarios, designers can evaluate propagation risk and implement strategies such as insulation, venting, or cooling to prevent cascading failures. To stay ahead, we need accelerated design approaches, thermal simulations, IP-rated protection against water and dust, and adherence to global standards such as IEC 6364 for low voltage installation or IEC 61439 for switchgear assemblies. We'll not go through all of them today, but you know them and you can read them. Materials must also meet flame retardant, and low smoke requirements, and halogen-free options are essential for sustainability. In short, compliance should be seen as a driver for innovation and reliability, not a barrier. By integrating these requirements early, we reduce risk, improve performance, and deliver safer and smarter solutions. Therefore, in the next slide, we'll take a specific example. This use case 3 is all about accuracy, precision, compliance. When we talk about success in design and installation, it's not just about big ideas. It's about getting the details right in collaboration with the OEM system integrator, for instance, from A to Z, ensuring the highest performance for the specific application. On the first image, we start with thermal performance simulation. This step ensures that heat dissipation and distribution is understood and managed before we even build. It's about predicting behavior under real conditions and preventing risk like overheating. Then, second image, so we move to the enclosure now, and it's not just a box. It's a compliant structure designed to meet evolving standards. Every component from airflow to material selection is tested to guarantee safety and reliability. And then finally, the third image, the battery integration. This is where electrical and thermal conditions come together. Proper integration means stability, performance, and compliance with fire safety and low emission standards. So no, compliance is not about a checkbox. It's a continuous process. From simulation to integration, every detail matters. This is how we deliver systems that are safe, efficient, and ready for the future. Edwin, the last is yours.
Excellent. Well, fabulous, guys, and many, many thanks for your valuable insights and tips. I have certainly thoroughly enjoyed listening to it all, and I hope the same applies to our audience. What I took away from it is that really a lot of attention to detail is required before a final BESS solution can be realized. And much of this detail is not visible, as we just heard from Robin and Sarah, to the eye, but it is imperative to get to an ultimate BESS solution to bring to market, something that is scalable and resilient. And if we don't do these things, if it's not taken care of adequately, it does run a high risk of delays. And of course, that is certainly something we all want to prevent, both from us as a co-development partner, but also from you as an organization that would like to roll out new BESS deployments to market, and preferably as quick as possible. What I hope that it will also stick with our audience is that in order to speed up your BESS productions, engaging with a systems protection and electrical connection partner such as nVent is worth exploring. Especially with all the considerations that we just heard about that can simply not be overlooked to get to an optimal BESS design and to help, as I said, realize the scalable BESS deployment, and basically also to help realize the scalable BESS deployment ambitions faster. So last but not least, I'm also happy that you shared the fact that nVent can support our listeners with various simulation tools during prototyping and testing, I think as part of the third challenge, to ensure that you can offer your most innovative BESS solution to the market. So rest me to say that I'd like to thank our listeners, and on behalf of the team, it's been a true pleasure, and we hope to hear from you soon. And in case you want to have a look on our website, do go visit nvent.com. And if you wish to link up with us for a personal chat, we're more than happy to listen to you and talk to you. And don't forget, therefore, to scan the QR codes on this slide. Once again, many thanks for your time and attention today. Really appreciate this. And wishing you a great rest of your day. Bye-bye, and let's be in touch soon.
Thank you. See you soon.
Thanks.